Hello everyone. Lab Unit 4 covers the theory and practices of liquid chromatography. Section A investigates how the flow profile affects separation performance. The flow profile mentioned here is about the composition of mobile phase used in LC. Generally, there are two types of flow profile. One maintaining the composition through the run, while the other changes the composition of the mobile phase during the run. The one without change in composition is called isocratic run, and the one with change is called gradient run. Now we can look at a few examples here. Please determine if any of the examples uses isocratic or gradient run. You may pause the video until you have all answers. Bingo! Yes, you had them correctly. The first three used isocratic run. No change in composition. And the fourth one used the gradient run because it changes its mobile phase composition. The purpose of gradient run is to utilize the difference in mobile phase polarity, which alters the retention of analytes. How do we develop such a method? Here are the general steps to follow. First, set a flow gradient in a wide range, typically changing from 10% solvent B to 90% B, in about 40 to 60 minutes. The blue line indicates the change in solvent B composition. From there, we will determine if a gradient run is necessary. The next slide discusses the criteria for the gradient run selection. If a gradient run is necessary, we will then look at the chromatogram. As indicated on the top chromatogram, there are blank areas where no peak is observed, such as before 13 minutes and after 36 minutes. Those areas contribute nothing to the separation but the mobile phase waste. Ideally, they should be eliminated. According to the flow profile, the blue line, around 13 minutes, the percentage of B is around 30%, while around 36 minutes, it is around 82%. Therefore, the composition of the flow will be modified to 30 to 82%. In the meantime, no change in overall runtime. If no compromise in separation performance after step 2, then modify the overall gradient so the run can be completed in a shorter period. The bottom chromatogram indicates the separation of 8 compounds was completed slightly over 20 minutes under optimized gradient condition, which shortens the original separation time to about 2/3. On the chromatogram, we'll also find the gradient time, which is the same as the running time. For this example, it is 40 minutes. Next step, we will calculate the difference in the retention time between the first and the last analyte peak, delta T. For this example, the first peak was around 13.9 minutes, and the last peak was around 35.5 minutes. Therefore, delta T is 35.5 minus 13.9, which is 21.6 minutes. The golden rule to determine if a gradient run is needed or not is to evaluate the ratio of delta T over Tg. If the ratio is greater than 0.25, a gradient run works better. If the ratio is less, no need for gradient run. For this example, the ratio is 21.6 over 40, giving 0.54, which is greater than 0.25. Therefore, a gradient run is necessary for this example. Now we will look at our experimental data. You should have 2 pages of data similar to the picture on this slide. On the top, injection acquisition method name reveals if this is going to be a gradient or isocratic run. Also, most of you have named your data with either isocratic or gradient. The other boxed area shows where you place your sample vial. For this experiment, the isocratic flow uses a mixture of 40% water and 60% methanol, while the gradient run changes its water content from 40% to 10%, while increases methanol composition from 60 to 90% over 8 minutes. 8 minutes is the gradient runtime, TG. The 9th minute is just to reset the mobile phase for the next run. You will then find the retention time and a peak width for each paraben. From the first to the last, the separation order is methyl, ethyl, propyl, and butyl paraben, which is determined by the polarity of parabens and the mobile phase. You will be only looking at the large peaks, not the small ones, which are the result of impurities. Once the time and width are determined, you will use the formulas mentioned here to calculate resolution, retention factor, and the ratio of delta T over Tg to determine if a gradient run is needed or not. Please be sure include all required information in your lab report and let me know if you have any question. Thank you.